Systems of linear equations. It's two or more linear equations. A solution is an order pair, an x value, a y value, that satisfies all the equations. Possibilities. Lines that intersect at one point have one solution. So we have two linear equations. They have an intersecting point. That intersecting point would be the solution for the linear equations. This is known as consistent, consistent meaning that there is a solution, and independent meaning they are two separate equations. So when you have one solution, it will be at the point of intersection where the two lines crosses, and it will be an order pair. And an example of an order pair here is a -1, 2. The next possibility is we have a system of equations that are parallel lines. Well, parallel lines have no solution. There's no point of intersection, therefore there will be no solution for this system to be true. So if there's no solution, then it's inconsistent. But they're still independent of each other because their lines are not the same equation. So parallel lines have no solution. The variable when you're solving the systems will be eliminated, and then you'll end up with something that does not equal the other. So an example here is if the variables were eliminated and you got 7 equals 8, well, there's no solution because 7 will never equal 8. So if the variables are eliminated and you get this scenario, there's no solution and my lines are parallel. And then the last possibility are coinciding lines, lines that are the same line. They end up being the same line. So if we have coinciding lines, we're going to have infinite solutions. Any value of x and y will work because they're the same line. So it's considered consistent because there is solutions, but they're dependent, and it's dependent because they are the same line versus different lines. So infinite solutions when the variable is eliminated. So when the variable is eliminated and you get something that equals the same thing, then we have infinite solutions or all real numbers. So when the variable is eliminated, if the two things aren't equal, then it's no solution. But if the variable is eliminated and two things equal, then there's infinite solutions. So the first method we're going to learn is the substitution method. And substitution method is step-by-step process. So the first step is you're going to be given two linear equations as a system. And you're going to solve one of the equations for one of the variables. And again, it's a literal equation. So you're going to solve for one of the variables. And then the next step is you're going to take whatever that variable equals, which will be an expression, and you're going to substitute it into the other equation's variable. And then you're going to solve for the remaining variable. So the process is to get one of the equations in terms of one variable so we can solve for it. Now once we solve for it, it'll probably be a multi-step equation. You're going to get an answer. You're going to get a value for that variable. And then you're going to take that value and substitute it into either one of the equations and find the other variable. And a key note here is you have to write your answer as an order pair. It's always written as an order pair. So be very conscious of that. So let's do an example for the substitution method. So the first step is to take one of these equations and solve it in terms of one letter. So you always want to look at the two equations and see which is the easiest to solve for one letter. So when I'm looking at these two equations, the 5x minus 3y equals 23 and the 2x plus y equals 7, and I want to solve for one of the letters, well, the second equation is the easiest to get y by itself because it's one step. So I would take the second equation in this case and I would solve for y. So to solve for y, I need to move that 2x over, so I'm subtracting 2x over, and I'm going to end up with y equaling the expression negative 2x plus 7. Or you could have wrote 7 minus 2x. The order doesn't matter. So now you have the equation in terms of one letter. So now the next step is to take that expression, that negative 2x plus 7, and plug it into the y of the other equation. So the other equation, the one that you did not solve for y, you're going to take that expression and you're going to substitute it into the y of the other equation. Now here, when you substitute it in, it's very important you use parentheses to sub it in, because you're going to end up having the distributive property. So be very careful when you're using the substitution method to take whatever that variable equals, use parentheses, and plug it into the other equation. So now you have a multi-step equation to solve. And again, a multi-step equation, you do the parentheses first. So I'm going to do the distributive property with that negative 3 to everything to that negative 2x plus 7. And I'm going to end up with 5x plus 6x minus 21 equals 23. So be careful with that distributive property. We're distributing a negative 3. The next step in a multi-step equation is to combine like terms. So they're like terms because they're on the same side of the equal sign. So I'm going to combine that 5x and that 6x, and I'm going to get 11x minus 21 equals 23. Now I have a two-step equation. So I'm going to add the 21, and then I'm going to divide through by 11, and I'm going to have my answer for x. So I have my x value is 4. So now I have part of the solution of the system. So I'm going to take that x value. So now that you have the value of x, you're going to choose one of the equations to substitute in and solve for y. I like to always choose the easiest. You can choose whatever one you want. I'm going to choose the second one here, and I'm going to plug in the value of x and then solve for y. So when I substitute x in, I'm going to end up having 2 times 4 plus y equals 7, and then I'm going to solve for y. So I'm going to get an 8 plus y equals 7. I solve for y by subtracting 8, and I get y equals a negative 1. So now I have my solution for x and y, and I have to write my solution as an order pair. And remember, it's always your x value first and your y value second. So the solution here would be parentheses 4, comma, negative 1, parentheses. That's the order pair. That's the solution for this system of equation. Pause and try. So I'm choosing the first equation to solve for y. It's the easiest. You could have chose the second, but you'll end up with fractions. So I'm going to solve for y. I subtract 4 from both sides, and I get y equals a negative 12 minus 4x, or a negative 4x minus 12, whatever way you wrote it. Now I'm going to substitute it into the other equation. You always have to use the other equation. So I'm taking that 2x plus 5y equals a negative 6, and I'm taking a negative 12 minus 4x and plugging it into the y of the other equation. And I'm going to have the distributive property here. So I'm going to do the distributive property, and then I'm going to combine like terms. Now I have a two-step equation, and I'm going to solve for x, and I'm going to end up with my x value is a negative 3. Now that I have my x value, I'm going to take one of the equations and substitute the negative 3 into it and solve for y. So I took the first equation, or I used the y equals a negative 12 minus 4x because y is already solved for itself. And then I just have to evaluate. So I have y equals a negative 12 minus 4 times a negative 3. When I do the evaluation, I get a negative 12 plus 12, and that equals 0. So now I have my x value and my y value. So the order pair would be a -3, 0. So remember to write your solution as an order pair. Pause and try. So in this case, you see that the y is already solved for itself. So I'm going to substitute it into the first equation, and I'm going to have a multi-step equation. I do the distributive property here, and notice the variable is eliminated. When the variable is eliminated, it's either going to be all solutions or any real number, or no solution. And in this case, it's no solution because 4 does not equal 8. So the variables are eliminated. I get 4 equals 8. That's false statement. Therefore, there's no solution. So we end up having no solution for this. So this is considered inconsistent and independent. Now we're going to talk about the elimination method. I'm going to give you steps and then I'm going to show you an example. The elimination method, both equations must be in standard form. And standard form is when you have an x plus y equals some number, and the coefficients of x and y are integers, and it equals an integer. So it's very important that if you're using elimination, it's in standard form. So the first thing you're going to do is you're going to look at the coefficients of all the variables. And remember, the coefficients are the numbers that are attached to the variables. And you need to have the same coefficient but opposite sign. So you need it to be the same number but opposite sign. The whole point of elimination is when you add down, it has to eliminate one of the variables. And in order to do that, you have to have the same number but opposite sign, because 3 minus 3 is 0, which would cancel them out. So you have to have the same variable, the same coefficient but opposite signs with one of the variables. If you don't have it, so you're looking and you don't have it, you're going to have to create it. In order to do that, you're going to look at the two equations and you're going to multiply either one or both of the equations by a number that is going to create that. So I'll show you what that looks like. And then once you have that, you're going to add down. And when you add down, one of the variables is going to be eliminated because it's going to be the same coefficient but opposite signs, which will create a 0, making it eliminated. And then you're going to solve for the remaining variable. So you're going to have the value of that variable and you're going to plug it in to either one of the equations and you're going to solve for the remaining variable. So let's see what this looks like. So it's in standard form. I have both of my system of equations in standard form. And the first thing I'm checking is, do I have a coefficient for the variable that has the same number but opposite signs? So when I look at this, I'm looking at step 1 and I see my y's have the same coefficient but they're opposite signs. So it meets the condition. I have the same coefficient with opposite signs for my y. So I can skip step 2 and go right to step 3. And step 3 says add down. So all I'm doing here is adding down. So I'm going to add the x plus the 2x, and that's going to give me 3x. And then that negative 2y plus 2y cancels out. That's the whole point, to eliminate one of the variables. And then I'm going to add the 4 and the 8, and I'm going to get equals 12. Now I can solve for x. So I'm going to solve for x, I'm going to divide through by 3, and I'm going to get my x value equals 4. So elimination is you need the same coefficient with opposite signs to eliminate one of the variables and solve for the remaining. So now I have my x value. At this point, it doesn't matter which equation you choose. You're going to take that x value and substitute it in to the x value of one of the equations. So I chose the first one. You could choose the second. I'm going to take that value, plug it into x, and now I'm going to solve for y. And this is a two-step. I'm going to subtract 4 from both sides. I end up getting a negative 2y equals 0. And then when I divide through by negative 2, 0 divided by negative 2 equals 0. So I end up getting my y value equals 0. Remember, you have to write your answer as an order pair. So my solution here would be x comma 0. So be very careful. Make sure you're writing your answer in order pair form. Pause and try. So you see in this case I can eliminate the y's. They have the same coefficient with opposite signs. And I'm going to add down and I get 5x equals 20. I'm going to solve for x. I get x equals 4. And now I'm going to substitute 4 into one of the equations. It doesn't matter which one you chose. I chose the first one. I substituted in and I solve for y. So I get y equals a negative 3. And remember to write your answer as an order pair. So the solution here is going to be parentheses 4 comma negative 3 parentheses. That's my order pair. So now here's the scenario where we're going to have to do step 1. So I'm checking to see, do I have a coefficient of the variable that has the same number but opposite signs? So I see the x's, it's 4x and it's a 1x. It's not the same number with opposite signs. My y values has a negative 3 and a positive 2. They're not the same number with opposite signs. So I'm going to have to create it. Now it doesn't matter which one you choose to multiply by, but I like to choose the one that has the coefficient of 1, because then I can multiply by the number that is the opposite of the coefficient for the other. So I look at this second equation. If I multiply the entire equation by a negative 4, I'll have the same coefficient but opposite signs for my x variable. But be careful, whatever you multiply by, you have to multiply the entire equation. So you have to multiply all the way through by that negative 4, because you don't want to change the value of that equation. You just want to create the same coefficient but opposite signs so that you can eliminate one of the variables. So I'm going to take that negative 4, I'm going to multiply it all the way through to that second equation. And I'm going to end up getting a negative 4x minus 8y equals a negative 56. So make sure you go all the way through to the 14. Now you're going to take that first equation and you're going to do the elimination. So now you're going to do step 3, which is to add down. And now you see that my x variable is going to be eliminated, and now I can solve for my y. So when I add down, I get a negative 8 minus 3 is a negative 11, and then a negative 56 plus 12 is a negative 44, and now I'm going to divide through by a negative 11, and I'm going to get my y value equals 4. So now y equals 4, and now I'm going to find my x value by choosing one of the equations. I like to choose the easiest one, so I'm choosing the second one, and I'm going to take that value for y and substitute it in. And now I'm going to solve for x. So I end up getting x plus 8 equals 14, and I'm going to solve for x, and I get x equals 6. So now I have my solution for this system, and I'm going to write it as an order pair, 6 comma 4. So make sure you always write your x value first and your y value second. Pause and try. So I chose to multiply through by negative 5 to the first equation to eliminate y first. So I end up getting a negative 20x minus 5y equals 60, and I'm going to add it to the second equation. So my y's are going to eliminate out. I'm going to get a negative 18x equals 54, and I'm going to solve for x, and I get x equals a negative 3. Now you choose whatever equation you want. I chose the first one. I'm plugging it into my x value, and I'm going to solve for y. So I end up getting a negative 12 plus y equals a negative 12. When I add 12 over, y is going to equal 0. Make sure you write your answer as an order pair, and it would be a negative 3 comma 0. So now I'm showing you when you're looking at elimination method and you're looking for a coefficient with the opposite sign. And I do not have a coefficient, the same coefficient but opposite signs for any of them. And I can't just multiply one of the equations to create that. So this is the example of where you're going to have to multiply both equations by numbers in order to eliminate one of the variables. Now in this case, the reason I'm going to do it, I'm going to eliminate y first because I already have the opposite signs. So all I have to do is multiply the first equation by 3 and the second equation by 5, and I'll have the same coefficient with opposite signs. Now you don't have to do it my way. You could do eliminate x first, but you're going to be multiplying one of the equations by a negative in order to do that. So I chose to eliminate y first. You have to take that number that you're multiplying by and distribute it to the entire equation. So I'm doing that for both equations. And I end up getting my two equations, and I have the coefficient of y to be the same coefficient but opposite signs. Now I'm going to add down, and I'm going to solve for x. So when I add down, y is eliminated. I get 54x equals a negative 270. When I divide through to solve for x, I'm going to get x equals a negative 5. And now I'm going to take that, and it doesn't matter which one you choose to plug it into. I chose the first one. I'm taking x, I'm plugging it into the x value of the first equation, and I'm going to solve for y. I get a negative 40 minus 5y equals a negative 60. Two-step equation. I add 40 to both sides, and then I divide through by a negative 5, and I get y equals 4. And then I'm going to write my answer as an order pair, and my solution here will be a negative 5, 4. Pause and try. So again, it doesn't matter which one you choose to multiply or eliminate first. I'm choosing to eliminate the y value first. I have to multiply by a negative 3 in order to get the opposite sign. So be careful. I get a negative 9x plus 6y equals a negative 30, and 8x minus 6y equals 30. Now I'm going to be able to eliminate my y, and I get a negative x equals 0, so my x value equals 0. And then I'm going to take that and substitute it into either one of the equations. I chose the first one, and I'm going to end up having a negative 2y equals 10, so I get y equals a negative 5. Now I'm writing my answer as an order pair, so the solution is going to be 0, negative 5. Pause and try. So in this case, I chose to multiply the first by 5, the second by 2. I'm going to be eliminating my x variable here. But now notice this, when I eliminate, I end up with all my variables eliminating and 0 equaling 0. Now remember, this case is when the same thing equals the same thing. That means I have infinite solutions. The variables eliminated, I have infinite solutions. This is considered consistent and dependent. So this is infinite solutions are all real numbers. So now we're going to do a systems of equations and application problem. So first thing I always do is I read the problem first, and I want to identify totals. Totals are the important piece in setting up the equation. So you plan to work 200 hours this summer mowing lawns and babysitting. You need to make a total of $1,300. Babysitting pays $6 per hour, and mowing lawns pay $8 per hour. How many hours should you work each job? So I'm looking for my totals, and when I read this through, I know that one of my totals is a total of 200 hours that I'm going to be working this summer. So one of my totals is hours, and my other total is dollars. So how much money will I need to make? A total of $1,300. So I have my two totals. Now, when I do the equations, I like to use variables that represent the wording, because when I do the solution, I want to know what I just solved for. So I like to use M. M's going to be my mowing lawns, or the hours for mowing lawns. And what I know about mowing lawns is that I get paid $8 an hour. And then I'm going to use B for my babysitting hours. So B represents the babysitting hours, and I know that I make $6 an hour for babysitting. Now, what I need you to understand when you're making these equations is we're going to be matching it up to the totals, what they're going to equal. So when I talk about hours, that total of 200 hours, well, the dollar amount doesn't matter. I'm going to work a total of 200 hours whether I'm making $8 or $6. So when I'm writing the first equation here, babysitting plus mowing lawns is going to add up to 200 hours. So I don't need the dollar amount with this equation. What I do know is that I'm going to babysit and I'm going to mow lawns, and it's going to total a total amount of 200 hours. So this represents the hour equation. When I want the total for the dollar equation, I need to associate the dollar amount with each activity. So in this case, I'm going to have $6 per hour for babysitting, and I'm going to have $8 per hour for mowing lawns, and that those dollar amounts are going to equal $1,300. So now this is the system of equations that represents this application problem. And now we can solve. And you can solve by substitution method, you can solve by elimination, whatever method you choose to solve for. In this case, I ended up, when I solved, getting mowing lawns was 50 hours and babysitting was 150 hours. So whatever method you chose to solve, you should end up with these two solutions. Now when you're answering an application problem, you will not be writing your answer as an order pair because you're actually answering the question, how many hours should you work each job? So you want to answer it by mowed 50 hours, babysat 150. So you're actually answering the question. Pause and try. So again, the equations here, we have senior citizens plus regular tickets. Total tickets is 636. And then when we talk about dollars, it's $6 for senior citizens plus $9 for regular tickets. And the total revenue in dollars was $4,974. Now I have my system, and you can solve it any way you like, and you should get that senior citizen tickets sold was 250 and the regular tickets sold was 386. Now this example is a little different. So we have, again, we want to read the application first before we start writing equations. So building A is 150 feet shorter than building B. The total height of the two buildings is 1,510 feet. Find the height of each building. So in this case, you have to be careful because I'm labeling A and B as building A and building B. Kind of makes sense. But at this first here, when I want to write this equation, it's telling me that building A is 150 feet shorter than building B. So representing that mathematically, well, what it means is that A is going to equal B minus 150 because it's building A is 150 feet shorter than building B. And when it's shorter, that means we're subtracting. So we end up having my first equation is just like the way that the words are written. A will equal the B minus 150. Now my second equation will be based on the total height of the two buildings. And because the two buildings add up to 150, I'm simply going to have A plus B equaling 1,510 feet. So when we're talking about writing equations, it's important to be able to read the words and interpret it mathematically. Now we can solve it any way you want, and because A is already solved for itself, I would use the substitution method here and solve. So I kind of did all the work for substitution method that you can see how it's done. I would take my A and substitute it into the second equation and solve for B, and then I would have my answer for A and B by plugging it in. So again, my answer here for building A is 680 feet, and building B would be 830. And you can see how I did the substitution method for solving. Pause and try. So in this case, the cement mix is equal to 5 pounds of gravel. So each pound of cement is equal to 5 pounds of gravel. And the mixture of the cement and the gravel is going to total 258 pounds. So both cement plus gravel will equal 250 pounds. So now I would use substitution because C is already by itself. I would plug it into the C of the second equation and solve. And I would find that my gravel here would be 43 pounds.